to part 2 of Competency 4. In this video, we will work with algebraic models. Okay, before we begin, make a note of the key that we're using. Now, when you take a test, they will give you a key or they'll make it very obvious which tiles are negative and which are positive, okay? And you kind of really have to work with the algebra tiles to discover their actual meaning in different cases, but for our purposes, it'll be pretty simplistic, okay? All right, so number one says, what is the equation that represents the following model? Well, make note that this green is x, okay? It's a positive x, rather. And there are two of them. So we need to say that there are two x's. Let me pull up my pen here. Okay, I see two x's. Now, the yellow ones for S, those are positive. So I see plus 4 singletons. And then that is equal to 2, 4, 6, 6 negatives. Okay, well, let's find that equation that matches. It isn't A, and I'm seeing B. I think B is it. Yes, B is it. And you can see why some of the others don't work. I mean, C left out a lot, and A left out our 4 singletons, and D, it said that our 4 positive singletons on the left-hand side were negative. So, and it also says our sixes are positive and not negative. So, I mean, our 6 negative singletons. Okay. All right, let's try number 2. Number 2, which model represents the following? X squared plus x equals -9. Well, the first thing I would do, it's pretty obvious, I would eliminate A because on the right-hand side with your -9, those are positive. Yellow is positive in our key. So I'm not gonna believe that one. All right, now let's look at our left-hand side. Notice that we only have x values. There are no singletons. There's no negative or positive, the red or the yellow singletons. So any of them on the left-hand side, if they have a singleton, they're not an option. See, this is an x and this is an x. There's no constants. So that being said, I can get rid of B and C. And what do I have left? I only have D left. And I believe that because here's my x squared, here's my x, and there's my 9 negatives. Okay? Right now, let's go to number 3. And if you haven't noticed, we're not using our calculator. This is just an either you know what you're looking at or you're not until you might go to solve something. That's different. Let's look at number 3. Which of the following models represents the solution of 4x minus 9 equals 3? Ah, that's completely different. So we had to know how to apply some algebra here. Okay, they want the solution. Okay, so I'm going to follow through with 4x minus 9 equals 3. So, of course, what do you need to do? You need to add 9 to both sides. So we have 9 here, and then I'm going to say plus 9 over there. Okay, this is eliminated. So now I have 4x equals, I'm going to leave the 3 plus 9. During a test, I don't calculate as I go. Okay, so this gives me what I need to put in the calculator. So, but what I'm seeing is on one side, I need an x by itself. A solution should have just a single x. Okay, well, let's look at A. that doesn't have what x equals. That's what they're looking for. So I'm absolutely not going to believe it. Okay. And then let's look at B and C. D, that's invalid. That's not a solution. That's still an equation. It hasn't narrowed it down to only one of these, which would be 1.5 of the negative. So no, I'm not going to buy that. So now we're down to B and C. Well, I can tell you, I see an issue already. I've gone through this process, and the expression here, this expression here, let me make this a little clearer. This is what I need. And when I put this fraction that I built in the calculator, that's everything there is positive. It is positive. So because of that, I know that I'm going to eliminate C and that all I have left is B, and I can pop that in my calculator and say 3 plus 9 over the 4 equals 3. There you go. Okay, let's try number 4. What is the solution of the following model? Okay, we could work this out algebraically, or we could just use a little bit of cancellation and division, and just by drawing. Let me show you. Okay, we want to keep our balance. Okay, we need to keep it equal. So I know that I can mark out 4 on this side, on the left side. And you know what? Here, let me erase this. Okay, then I will mark out the top 4. Okay, those are all gone. And actually, if I use the white, let's see what happens. Okay, yeah, I can literally just like white these out so they don't even, they're not like almost just not there. Okay, so if I got rid of those guys, okay, let's say they're not there anymore. Okay, now, all right, oh, that's nice. Okay, so now that I've done that, that's cancellation. Now I'm still balanced because I took 4 off of one side and 4 off the other. Now, what if I split up? I split up things to keep them balanced. Okay, watch. Let's go back to the color that I had. Okay, so let's divide things out. If I take 1 off of this side and 2 off the other, then I know that I'm still going to be successful, right? Let's see, I've got a little issue. That didn't work as good as I thought it would there. Okay, I need to let me take that out there. Okay, but we were getting rid of that. Okay, for some reason when I drew that, okay, that just didn't work. All right, so we know that if we split that evenly, I'm still balanced. So by doing that, I also can take that off, okay? So if I take that off of each side, oh, I've changed everything here. Sorry about that. Okay, so then I know that I have an equivalency here that I can work with, okay? So that means for every x, 2 singletons will weigh the same. That's balance. So there's my answer. I can use cancellation and then I can divide things out. That's very valid. So that means that I have 1 is equal to 1x and x is equal to 2 singletons. Well, that's x equals 2, which has to have to be option B. I know that's not, it doesn't seem like it's not what we were taught. We were taught to do everything algebraically. Well, why can't you do it on a picture and just take the same things off of both sides? Okay. All right, let's look at number 5. We need to pull that up. Look all of number 5. Okay. Which of the following models has the solution x equals 7. Okay, well, we would actually have to solve, and this looks, yeah, we're gonna have to go through a process on each of them. Okay, let's see here. If I took an x off of both of these, I'm looking at A right now. If I took an x off here, I have to take an x off here. Okay, that leaves me one x. Now, to get rid of the singleton, I would have to subtract it over here and then subtract it over here also. I see x equals negative 1, 2, 3, 4, 5. Nope, A doesn't make sense. Okay, well, for B, if I subtract 4 on the left side, okay, then I have to subtract them over here, which means I have to put the negatives in here. Okay, and then after I do that, then I have to divide out. Okay, so I see x equals 1, 2, 3, 4, 5. Nope, it says 7 and it's a positive 7. B doesn't work. Okay, now look at what's going on here. Let's look at C. I have 3 singletons. When I get rid of those and I put 3 singletons over here, everything is going to be negative. Even when I divide out, it's still negative. I'm looking for a positive. I don't believe C. Let's look at D. Okay, I have 4. 1, 2, 3, 4. If I add 4, I plus them out, basically, is what I'm doing. That will get rid of these, okay? And that'll move 4 pluses because I plussed them to be opposite to create a 0 pair. That gives me 1, 2, 3, 4. I need to put 4 there. Oops, that's a plus. So now I have 7 positives on the right-hand side. And if I use cancellation to get rid of the x's on both sides, then what do I have? I have, well, it's just what do I have left? I don't need to divide out or anything like that. I have the single x on one side, on the left side, which is what I want. And then I have 7 positives. So D is the only thing that really works. And if you want to write that out algebraically, you can. But I don't see a reason if they give you the models, the pictures, why not use the pictures and draw on those? If you know the process, you shouldn't have a problem, okay? And that's the thing. We do need to know the process. Okay, this is the last question in this video. And again, thank you guys so much for watching and subscribing. Happy testing.